Good morning. Budi Raharjo here from Padepokan Budi Raharjo. Let's start with ngopi dulu. Coffee first. This is nice coffee from Gunung Halu, which is Gunung means mountain, Halu mountain, close by, and with Bali. So it's a mix of Gunung Halu and Bali. I made it into cappuccino. This is a nice coffee morning, Sunday morning in Bandung, West Java, Indonesia. So I've been playing with IoT lately, and I got this device from a friend of mine, Mike, and he brought OpenMPPT. You should look into OpenMPPT. This is like a device. I don't have it right now here because I installed it in the box outside. But let me show you what it is. Okay, so this is okay. What we are doing is we created this box. Hang on a second. So this is the box that I have right now. Let me just make it bigger. Okay. So this is a box. We call it self-sustained IoT box. We can carry this box all around. So there's a solar cell sensor on top of this. This is kind of a prototype. The first or the alpha version of our self-sustained solar system. So this is our solar cell, and this solar cell is connected to a box. This is the OpenMPPT box, and it has 3 connections. One connection is to the solar cell, and then the second connection is to this battery. This is a battery from a motorcycle, new one, 12-volt battery. And then the third connection is connected to this. I don't know if you can see it. It's a ASP 8260 stick. Node MCU. I think this one is Node MCU Mini D1 from VMOS, and it is connected to a humidity, temperature and humidity sensor, DHT22. Okay, so it's connected like that. So basically, those are the components: the solar cell to get the energy from the sunlight, and then we have the energy collection. This is the box, like the battery, and then this is the device that we want to use and connect it to the internet, like this is. Okay. Now in this OpenMPPT box, there's also a sensor here. I think the sensor is connected to the battery to make sure that the battery is not very hot because of overcharge. I think I put it wrong. Like the sensor has to be somewhere here. Right now it is kind of directly hit by sun ray. So when the box is hot, kind of, it's probably hotter than the battery itself, the temperature of the battery itself. But anyway, so this is the setup that we have right now, and I'm trying to understand the characteristic of this. Okay, so I wrote a small program. So this is it. Okay. Oh yeah. This is the more like the internal from the other side. So you can see this is the OpenMPPT box. And then this is the battery, and this device is actually I think DC to DC step down voltage, because my Node MCU requires 5 volt and this battery is 12 volt. So there is a kind of a step down from, can't remember. It's not 12 volt, but 8 volt or something. The output of this OpenMPPT, and we have a step down, and this step down converts that voltage into 5 volts, so we can use it. So this is just use it for our IoT device, and I have these are just fuses just to make sure that if there is a short circuit, it's not going to blow my components. So anyway, this is a simple box prototype. Now, what I'm trying to do is to understand, because I don't understand this. This is new to me, so I put all the things together and then play with it. Okay, hang on a second. Let me just drink my cappuccino. I'm almost done with my cappuccino. I need to make another one, probably V60. Okay, anyway, coffee is gone. Let me just continue with my. So, what I'm trying to do is I'm trying to plot. Okay, hang on a second. Let me just plot this. Okay, so this is the plot of the solar cell. I started yesterday, I think afternoon around 4 p.m. So I just wrote the code, slapped some code together, and then this is a way to find out the the voltage of the solar panel. The OpenMPPT, the device has this kind of probe. It has this kind of information. So I just pull it from this OpenMPPT device. It has a small web server. So I just query the page, and this is what I got. So I thought that the solar panel will deliver kind of voltage varying from whatever voltage is 15 volts, and then it goes down because it's darker, right? Less sunlight, so it goes down more like an analog fashion. It is analog. The voltage is analog, but it didn't occur to me that it goes straight from whatever it is, like 14 volt or whatever it is. It goes down. It went down to 0. And then there's a spike. I don't know, maybe there's some kind of charge left in the solar panel. And it went to 0, 0, 0, 0, 0 because it's night here. Okay, yeah, okay, understandable. Then there's no voltage from the solar panel. And at 6:30 in the morning, 6:30 in the morning in Bandung time, West Java, it suddenly went up to, I think this one is around 12 volts, right? 12 volts, and it goes up. It went up, and then it's about 8 p.m. This is about 8 p.m. like probably half an hour ago. So this is not real time. Actually, the data is real time, but the plotting is not real time. So I just took the data and then plotted. So I thought the solar panel, it has to go like an analog. It goes down smoothly, or maybe sharp, but at least it's not like this from 12 volt or 14 volt drops suddenly to 0. So that's the thing that I learned. Is that common in solar panel? So you have like certain kind of volt, like 12 volt or 14 volts or whatever, and it goes down directly to 0 and then goes up. Is that the behavior of a solar panel? I have no idea, but that's what I have. Okay, now so that's the solar panel, right? And then let's see. Now this one is the output of the MPPT, like the box itself. So basically, it has some sort of correction. It follows the solar panel voltage. Okay, so this is the temperature, right? But battery voltage. So the battery voltage swings around 12 voltage, like this one, exactly 12 to 50, 12.2, right? 12.2 up to 12.4, like. So it went down from 12.4. This was 4 p.m. and it went down because the charging. It's not there. So, but it is still above 12 volt. So I thought it's going to be like this, right? Maybe roughly around 12 volt. But apparently, it goes up. It goes up and down, but it's still around 12.2 to 12.4, like. So this morning, during night, it went down, and then 6:30 it went up again, but it's still around 12.3 volts. So it's good battery voltage. Now, the temperature, this one is the temperature of the battery, the temperature inside the box. It went down from 34 degrees centigrade Celsius, went down because it's night here. It's night in around my house, nighttime, it is around 23 degrees Celsius. So this one is around 24, 23, 24, right? Inside the box. And then this morning, because it is kind of under sunlight, it goes up, and usually it goes up until 35 here. Normally, like outside temperature, it's around 20, 25 or 27, like around here. But inside the box, it goes up, right? Okay, so that's the temperature. And now this one is the charging. So when I started this coding, it was around 79% charge, the battery, and it went down. Obviously, because the charging, because it went from afternoon, it went to night, so there was no charging, and the battery was discharged because of the usage of my IoT system, and it went down until 66%. It should go up after charging this morning, right? We'll see. So that's what's going on in my battery system. So now going back to the issue. So we have this box, and I'm trying to understand this box, and I'm trying to understand the issue also in getting the data. For example, right now, the temperature and humidity, the sensor, I think I captured the data maybe 30 seconds or 1 minute. Get the data from the environment and then push the data using Wi-Fi to an access point close by. So anyway, the device itself, the Node MCU, it's always alive. So it's consuming energy. I don't know whether we should put it into sleep, say get the data, send it to over Wi-Fi to a server, and then go to sleep, say 5 minutes, and then after that, I'll wake up and do the thing over and over again. But there's a sleep, like a 5-minute sleep. Would it preserve the battery more? I don't know if the effort is worth it. I think for this case, it's not worth it. But I'm trying also to change the battery. This one is like a huge motorcycle battery, but I want to change it into like a rechargeable, smaller batteries, like one of those double A's, or maybe a bigger one, right? But at least it's smaller and more compact and less heavier compared to the one that I have right now. Is it suitable? Is it better? For now, it's okay in my opinion. But if I want to make if I use smaller batteries, then I have to make sure that I'm kind of use the energy properly. So I'm going to measure that one. And then the other thing I have not played with is the Wi-Fi, the networking. I'm going to change it from Wi-Fi into LoRa. Would LoRa use more energy or less? I think it's supposed to be less, right? I'm not sure. So that's I'm going to check. A better way would be to measure the current of the device. So before the device, before the voltage goes into the device, the Node MCU, I should have something to measure the current. I don't have the device right now. Maybe I should create a smaller device or use some create like a measuring device to measure the voltage and current. So I can, if you multiply voltage and current, you get power consumed by the device. Maybe it's a better way to do it, and it's actually much better way to do it. But right now I'm just measuring the whole thing from the environment, so which is not very accurate, or maybe it's accurate. I have no idea, like the accuracy of the my configuration right now. Anyway, so that's that. I hope you enjoy this video. Let's share what's your experience in terms of self-sustained weather sensor. Most of the videos I've seen on the internet, they're kind of trivial once you get it done, but in terms of real project, a real device that is being used in real production, I have not seen many videos of that. So my aim is to create that kind of video. So for those who want to use or who want to create this in a real production, it could be very helpful. Our plan is to put this in an ocean close to Aceh, and also probably close to Makassar, Maros, close to Makassar, which is in the ocean or in some sort of remote area. So it has to be self-sustained, because we don't want to go there often, because it takes quite a bit of time flying from my city to there, and then from the city it goes to like a the ocean maybe takes 2 hours, so it's not worth it, or it's a hassle. So we have to have some kind of self-sustained system that can be used, like maybe if we service it like once a year, it should be okay. But we don't want to go there every week. So it's supposed to be reliable, resilience in terms of the environment. We'll see how it goes. So good morning. Stay safe, stay healthy, and drink lots of coffee. I need to make my another cup of coffee, probably V60. It's better approach, probably it's better idea. Anyway, bye.